All right. So on this right here, we're going to talk about problem-solving technique for word problems for critical response questions. And the first thing that you do is you identify the question. And I identify the question by going to the very end of the problem. I'm highlighting it because you do have a highlighting feature on your ACT Aspire testing. You can highlight that, and you can click it and highlight the question. Now, from there, we are going to trim the fat. In trimming the fat, we're going to identify the mathy words. Sum, difference, product, quotient. I look and see if any of those show up. Pretty much in your grade level, you won't have a lot of those, but if I have some of that, it automatically triggers what math operation is happening. So if I don't see any of those, which I don't have any, I start looking for two things. I start looking for three things. One, I look for numbers down there in just a minute. But two, I'm going to look for units of measure and actions of numbers. Words that create actions of numbers. Like where the other day. Where told us it was going to be a location. That was where the actions of numbers came from. So in this one, we obviously have find for the action of numbers. So I know I'm going to be doing some solving instead of locating. Okay? And it says find the number of students in each van and in each bus. So my units of measure are van and bus. Those are my units of measure. Okay? And the only thing that identifies numbers are the words each. And each represents a single person, a single unit, a single measure. And so therefore, I should start getting in my brain that this is not going to be a huge number. Okay? Not going to be a huge number. And now then, as I look over here, there's one more unit of measure, and that's students, and that's representing of my total. So I know that vans and buses equal a total number of students. That comes directly from the question. It comes directly from the one question at the bottom. I haven't even looked at the passage yet. And so the last part is we're going to go up to the passage and we're going to circle the numbers. All right, so here's 459, here's 15 and 4, here's 332, here's 10, and there's 7. Okay, and so I got those numbers. So what I'm going to do is I'm going to bring those numbers down. Okay, and I'm going to write them in order. I got 7, 10, 332, 459, and then I got 4 and 15. So those are my numbers, and this is where from the question the units of measure helps me. I'm looking for students, vans, and buses. And so out beside it, I see 459 students. So I know that this is students. I see 15 buses. I see 4 vans. I see 332 students, which is right beside it. I see 10 buses, and I see 7 vans. And so now, just by looking at that, and this is a little bit by the luck of the draw or the design of the question, it tells me my two equations. I have this equation that represents this group, and I have this equation that represents that group. And so, I know that 7 vans plus 10 times the number of students on the bus is going to equal a total number of students in that group. And I know that 4 vans multiplied to the number of students on that van added to 15 buses multiplied to the total number of students on those buses is going to equal 459. So looking at this, what would be the best way to solve? Now we're going to solve by graphing. Which would be the best? Huh? Why is that? Very good. I don't have a coefficient of 1, so that takes substitution out, and that's also a characteristic in elimination. So I go, oh my God, I can't do it. Well, I know dang well that I don't have a variable by itself. Right? So substitution is completely out because both of those characteristics of the problem are gone. Elimination, at least both are in standard form. Now this isn't the easiest elimination problem in the world, but it's not that hard because they're both in standard form. So elimination would be the most efficient, but we're going to use graphing. To be honest, graphing is just as efficient as elimination for this one, if you have a calculator feature. If you don't have a calculator, I wouldn't do graphing because these numbers right here are going to be big. And I don't want to hand draw graphs that big. Okay? So, now we got to do the work. We're going to take that one right there and we're going to solve for b, because this represents my x, this represents my y in standard form, so therefore this is my x, this is my y, and so therefore I'm going to solve for b. When we solve, we use what? Very good. Very good. So I'm going to subtract 7v from both sides. 10b equals negative 7v plus 332. I'm going to divide by 10. Negative 7 divided by 10v plus 332 divided by 10. Yes, I could go ahead and divide that and get 33.2. But if I'm going to use a calculator, I'm going to let it take care of my fractions. And so in my calculator, y1 is going to equal parentheses, or negative parentheses 7 divided by 10, close parentheses x, plus open parentheses 332 divided by 10, close parentheses. Okay? And we already don't like it because there's a lot of fractions.
But it's not bad when you happen to do that.
It's not bad when you use the tool for what it's used for. All right? What it's designed for. So we're going to do this one right here. Okay? So I have 4v plus 15b equal to 459. Order of operations from bottom to top. Subtract 4v from both sides. We got 15b equal to negative 4v plus 559, or 459, sorry. 459. We're going to divide by 15 to both sides. b equals negative 4v plus 459 divided by 15. And so I convert this to slope-intercept form. This is going to be what I put in my calculator. y2 equals negative, open parentheses, 4 divided by 15, close parentheses, x, plus, open parentheses, 459 divided by 15, close parentheses. And those are my two equations. All right. So now we are going to graph them. So y1, negative, parentheses, 7 divided by 10, close parentheses, x, plus, open parentheses, 332 divided by 10, close parentheses. There's the first equation. Second equation. Negative, open parentheses, 4 divided by 15, close parentheses, x, plus, open parentheses, 459 divided by 15, close the parentheses. Graph. Oh my God, it didn't work, right? There it is, right? Why would it not work? Because my y-intercepts are 33.2 and then some other number that's bigger than 10. So I'm going to zoom out so I can see it. There's one of them. There's the other of them. There's the point of intersection of them, which is the solution to the system for them. All right? So now I go second trace. We do not speak of trace.
I was about to say.
Establish that. Pass the point of intersection. Bada bing. Bada boom. Solution is 6 and 29. 6 and 29. Right there. 6 and 29. So therefore my solution is 6, comma, 29.